Hello, it's time for topic 1, skill number 3, which is still solving equations, but in skill 3 we focus on moving variables to one side. At this point we know from skill 1 how to solve a two-step equation, and that involves moving numbers from one side to another by doing the inverse operation. So we know how to work that way. However, we haven't talked yet about how to move variables. Well, we're really doing the same thing when we're moving variables to the to another side. We still have to do the inverse operation. The big idea, I know this is a lot to read, is that when equations have variables on both sides of the equal sign, you need to move all the variables to one side before you start to do the inverse operation. So get all the variables together, combine those like terms, and then solve the equation. Example 1, 2x plus 5 equals 6x minus 2. Now you can immediately see, and some people like to draw a line through the equal sign so that you can see both sides of it, that I have an x term on this side and an x term on this side. So before I can start to solve for x, I have to only have one of them. In the past, those x's were on the same side, so we could just combine like terms, but now that they're separated on different sides of the equal sign, we have to move one of those terms to the other side. I generally like to move the one from the right over to the left, just because that's normally where we see our variables on the left-hand side, but technically you go either way. So to move that 6x to the other side, we have to do the inverse operation. The inverse of a positive 6x is a negative 6x. I want to do a little bit of clarifying here. We're now not looking at the operation between the 6 and the x. I want to take the whole term, 6x, and move it to the other side. So when we do that, we have to look at either is it being added or is it being subtracted, and do the inverse of that operation. So if we subtract 6x on this side, we also have to subtract 6x on the other side. I also, in general, when I'm moving an x term to the other side, I line it up directly underneath the other x term. Just like our other equations, these two terms are going to cancel out because they are inverse operations. What's going to be left on this side is negative 2. And then on the left side, I can see I have 2x plus 5 minus 6x. Well, now that I have my x's on the same side, I can combine my like terms, 2x minus 6x, and I can do 2 minus 6 to get negative 4x, and the plus 5 comes down. Now I have just a two-step equation, which we're comfortable with at this point, so we can subtract 5 on both sides. And then the last step that we need to do is move the negative 4. Right now it's being multiplied, so we will divide the negative 4. So we're left with x equals negative 7 divided by negative 4. If I plug that into my calculator, I get 1.75. Example 2 I see is a little bit tougher because I see I have the parentheses, which should trigger that we need to start with the distributive property. Now, even back, if you think back to skill 2, we did the distributive property before we started to solve any kind of equation. That is still going to hold true here. So before I want to think about moving any x to the other side, what I want to do is do the distributive property. So what I'm going to do is distribute that 2. 3 times 2 is 6x plus 2 times 1 is 2 equals 6x plus 2. Some of you may see something a little weird happening right now, but for the sake of keeping with the steps, I'm going to keep going. So I want to take this x and move it to the other side so that I can have all of my x's together. I'm going to do the inverse operation. So right now I see it's a positive 6x, so I will do the inverse, which is a minus 6x. These are going to cancel out. I'm left with a 2. And now, since the x's are on the same side, I can combine these together. 6 minus 6 equals 0x. So these equals 0x. Do I ever write down like a 0 or a plus 0? I really don't need to. So I don't even write down 0x. What's left is a 2. Now, sometimes when we solve equations, the x's are going to cancel out. And when that happens, one of two things can happen. We could either have a statement left that is true, and if the statement is true, like what we have here, 2 equals 2, that is true. What that means is I have infinite solutions. Which just means that instead of having x only have one value that works, any value that we pick for x to plug in up here in the original equation, we could pick anything and it would work. Please make sure to write that down. If the statement is true, we have infinite solutions. If we have a false statement, after my x's go away, in some situations, I might see something that says 1 equals 2. In this situation, it is not true because 1 does not equal 2. So in this situation, we would have no solutions. What that means is back here in my original equation, no number that you could pick in the entire world would make it work. So again, if my x's cancel out, I either have infinite solutions or no solutions based on what is left at the end after they cancel out. Last example, I see I have a lot of different p's happening. My first reaction is to always start with the distributive property, distribute that -4 throughout before I even start moving anything else around, do the distributive property first. So multiply -4 times 3p and -4 times -5, which is positive 20. Be careful with that sign. And then everything else comes down. Next, what I now see is that I have p's on the same side of that equal sign. And again, back in skill 2, we can combine those two before we start actually solving. I can combine those two, -12 plus 2, to get -10. And then everything else comes down. Next step, I now see I still have some p's that are on different sides of the equal sign. And so I want to move those over. I'm going to move this one to the other side. The inverse of a -10p is going to be a plus 10p, and I'm going to do that to both sides. Those are going to cancel, being left with 6. The other one is, let me see, -10 plus 10. Well, that's going to equal 0p, so I'm not going to write down that 0p. What's left is 20. So I have 20 equals 6. Now, my variables canceled out. That doesn't always happen, but when it does, one of two things have to happen. Infinite solutions or no solutions. In this case, this statement is false, which means I have no solution. No value of x will ever work, no value of p will ever work in this problem. Not going to happen. So remember those basics as you move forward and solve more complex equations. You might have one solution if you're left with x equals something. You might have no solutions, or you might have infinite solutions.